what is the limits? Okay, if the values of fx becomes arbitrarily close to a single number L as x approaches a from either side, then the limit of function can be written as like this. Okay, so let me give you an example of this graph. So this is a quadratic graph which is the function given is x squared minus x plus 1. So for the limit of the function is given here. But the question is how we get the value of 3 here. So by looking at this graph, we can see that when x approaches to 2 from the right and when x approaches to 2 from the left, then we got the value of fx approaches to 3. So that's why we got the number of 3 here. Okay, for computing limits, we have two, which is the first one, limit of polynomials and rational function as x approaches to a, and the second one is limits involving radicals. Okay, if p is a polynomial function and c is a real number, then the limit of function px as x approaches to c equal to pc. That means we just need to substitute the limit value of x approaches to c into the function, then we will get the answer. If f is a rational function given by fx equal to px over qx, then the limit of the function is given here. So when we substitute the value of x approaches to a into the function, then we will get this equation. So the condition here, if QA is not equal to 0, if denominator is not equal to 0, then the limit of function fx x approaches to a equal to fa. And what if the denominator of or the value of QA is equal to 0? Then if QA is equal to 0 but the PA is not equal to 0, then limit of function does not exist because 1 over 0 equal to does not exist. The second one, limits involving radical. When we evaluate the limit that involves a radical function, we use direct substitution to see if a limit can be evaluated whenever possible. If not, other methods to evaluate the limit need to be explored, such as for radical usually we use multiply with its conjugate. Okay, what is continuity? A function f is continuous at x equal to c when these three conditions are met. The first condition is fc is defined. The second condition, the limit of fx x approaches to c exists. That means the left limit and the right limit have the similar value. And the third condition is the limit of fx x approaches to c equal to fc. That means the value for the second condition and the value for the first condition have similar value. Then the function is continuous. Next, properties of continuous function. If the function f and g are continuous at c, then f plus g is continuous at c. Then f minus g is continuous at c. F multiplied with g is continuous at c. And the last one, f over g is continuous at c if gc not equal to 0 and has a discontinuity at c if gc equal to 0. That means if the denominator is equal to 0, then the function has a discontinuity at c.
So now I would like to explain about what Sonia have taught earlier in her introduction regarding the limits involving radicals. So here's an example of how we can solve a limit involving radicals. Radical here means this is type of the radicals is meant, which is there's a surd. Whenever there's a surd, either doesn't matter on the numerator or denominator, we will use this kind of formula to solve it, where we use the technique called conjugate. So if you see here, directly if you just substitute the value 9 into the formula, you will get 0 over 0, right? So in this case, 0 over 0, that's not the answer. It's already, we know we have to do something to it to make it, we get the answer, final answer. So what we can do is, we write back and then we do conjugate. Conjugate where we take the one with the third one, the whole equation, and we multiply into like this. So this one is called as the conjugate technique involving radicals. So now, as usual, we just do the usual multiplication on the top and on the bottom. So what we do is we just multiply directly. We will get the answer plus 9x minus 3x and minus x third x. Meanwhile, on the bottom one, when we multiply directly, we will get 9 minus x. Yeah. Okay. So, and then we can make it into a simpler form, simplify it basically. How we do is we can take like this and then plus third x 9 minus x like this and then 9 minus x. Right? Now you can see something that's a very like similar, right, on top and bottom. When we see such similar values, we can just cut out of them just like that. Okay, so here similar, we just cut out that part. Balance 1 is this, right? So this one we can just substitute the value right now. This one into the formula where we get 3 9 plus third 9, right? So when we solve, we will get this one, we get 27 and 27, right? So it's already 0 plus third 9, we get the answer 3, right? So yeah, so we get, that's the answer. Yeah, that's all from me. Thank you.
Hi students, so today we are going to look at an interesting topic, which is limits of polynomial and rational functions as x approaches to a. Alright, so now let us look at the theorem. Okay, here we have a theorem. For any polynomial, this is the general theorem where px equals to c sub 0 plus c sub 1x plus so on plus c sub n x to the power of n, and this is for any real number a. So make sure you remember this theorem so that it is easier to approach a question. Alright, let's look at one example question. Alright, today this is the question for you all. Okay, look at the question. Limit, okay, we need to find the limit x squared minus 4x plus 3 when x approaches to 5. Remember this. Make sure you have to look the x value, the limit, when x approaches to 5. Alright, before we answer the question, we have to make sure this is the polynomial. So how to find whether this is a polynomial or not? Okay, x squared. Here we have an x squared term. Alright, next we have an x term and then we have a constant over here. So it satisfies all the terms. So x squared term, x term and constant. So this is a polynomial. Okay, so it is a polynomial. So what is the int? Okay, first look at the limit. What is the limit over here? 5. And then we have to substitute the x value into this limit question. Alright, so we have x squared minus 4x plus 3. Alright, so this is how we write this question. So limit x squared when x approaches to 5. Okay, make sure you remember this writing. It's very important.
So what is the next one?
Minus limit for x when x approaches to 5
Yes. So the next one.
plus limit 3 when x approaches to 5.
Okay, good. So now we're just going to substitute the 5 value. Okay, the value 5 into this equation. So it will be 5 squared minus 4 times with 5, okay, plus with 3. So here you can get 25 minus with 20 plus 3. So what is the final answer? Your final answer will be 8. Okay, so this is a polynomial question, and first remember you have to look at the limit. We have to identify whether it's a polynomial or not, and next we just need to substitute the x value. Okay, I hope you will understand this subtopic for today. Thank you.
Students, today we are going to learn about continuity of polynomials and rational functions. This one is one of the subtopic of limit and continuity. So for this subtopic, we have two theorems. The first one is a polynomial is continuous everywhere. So this one is the direct one. So the second one is a rational function is continuous at every point where the denominator is non-zero and has this continuous at the points where the denominator is 0. So this is if a rational function is continuous, the denominator cannot be 0. So if the rational function is discontinuous, the denominator has to be 0. So this is the second theorem. So for the example questions, for what values of x is there a discontinuity in the graph of, okay. So as you know, this is a rational function. So to find the discontinuity, what we have to do, Sangeeta?
So to find the discontinuity, the denominator should be equals to 0.
Yes, we have to make the denominator equals to 0. So x squared minus 5x plus 6 equals to 0. So we have to factorize it. So x minus 2, x minus 3. So the x equals 2 to 3. So this one we can summarize as if discontinuity. So yeah, that's all from me. Thank you.
Now moving on to the conclusion, we already go through some subtopic in limit and continuity. From what Yogastri has explained to us, which is about limit involving radical, we often encounter the expression that initially appeared in determinant, which is 0 over 0. So to handle these cases, the conjugate technique is being used. The question is how to do the conjugate technique. Okay. So the conjugate technique is we multiply both the numerator and denominator by the conjugate of the radical expression, and then we simplify the problem into a form where the limit can be easily evaluated. This technique helps eliminate the square root of the function and simplify the fraction. Next is about limit of polynomial and rational function. As x approaches a specific value of a, specific value of a can be a numbers like 1, 2, or maybe -1, but it also can be negative infinity or positive infinity. From what Sangeeta has explained to us, the process to solve limit of polynomial and rational functions is a very straightforward. For polynomial, we can simply substitute the value of a into the expression. From here, I want to say that for polynomial functions, it's just very simple step, which is you just substitute the value of a into your function and then you will get the answer. But for rational function, it will result in two cases. First, let's say that the provided denominator does not become 0, we just substitute the value of a directly. But if you try substitution that give indeterminate form, which is 0 over 0, further technique is being used, like factorization or simplification are needed to resolve this problem, right? Last but not least is for continuity. From what Jasmine has explained to us, for continuity, particularly for polynomial and rational function, first let's see for polynomial continuity. It's continuous everywhere, meaning that their graph have no breaks, jumps, or hole. It can be defined at any points. But for rational function, like I explained before, it results in two cases. First is when the denominator become non-zero. When it become non-zero, the continuity are same like polynomial function. But when the denominator becomes 0 at a certain point, the function is automatically discontinuous. Alright, I think that's all from us. Thank you.